Before we move on to the next set of features and logic, let's take a second to review our code. When we first learned about building apps, I talked about refactoring. Refactoring is the process of changing the structure of our code without changing any functionality. We've got a bit of our functionality going in the app, but already I think our view controller is becoming a bit unwieldy. This is a good time to maybe improve our code. I should note that over the next few videos, we're going to be using some concepts that you haven't fully learned yet, but will soon. So take this as a series of bonus videos. It's up to you if you want to implement these changes, but I highly encourage you to just watch along anyway. Let's review our potential set of problem areas. The first thing I don't like is the fact that the code that sets up our different views is all over the place inside the view controller. And I'm talking about the page controller at the moment. We've declared the labels and the buttons up at the top over here as stored properties. Then there's some setup code related to these image views, buttons, labels, and so on inside View.did_load, as you can see here. And then finally, there's some more in View.will_layout subviews. In fact, View.did_load does a lot of different things, and its responsibilities aren't entirely clear or straightforward. One of these responsibilities, as you can see here, is creating an attributed string with a certain set of styles. This doesn't really need to be in View.did_load. Maybe we can put this elsewhere. We're also setting up buttons with choices. Perhaps we can get all of this out of View.did_load as well. So how do we proceed here? Recently, we learned about lazy stored properties, which are stored properties that aren't created until the need arises. There's an interesting thing we can do with lazy stored properties that can help us clean up our code. Now, you haven't learned about this yet, but we can also create what are called anonymous functions that are immediately executed. And we're going to use that to improve our code to make a few changes so that we can either group all of the logic in one place and get it out of these methods altogether. So let's look at how we'll use these concepts. I'm going to go back up to the top. Imagine we had a stored property, a variable named a property, to which we assign the value 1. Now, instead of assigning this value 1 directly, I'm going to assign a function to it. Now, what you see here, just an opening and closing set of braces that has nothing in it, this is an anonymous function or a closure. And you'll learn more about this pretty soon, but essentially think of this as a function without a name right now. So this works exactly like a normal function. So inside it, I'm going to return the value 1. All I've done here is define the function, and if you check the type of a property, it's the function signature. So it's a function that does not take any values, no arguments, but returns an integer. With regular functions, when we want to call it, we write the name of the function or the method, and then using a set of parentheses, we call the function, passing in any arguments if the function needs it. With functions that don't take arguments, this means putting an empty set of parentheses right after the function name to call it, as you can see here in View.did_load. So it's just the function name and a set of empty parentheses. Since this function that we just wrote is not named, to call it, we can place an empty or a set of empty parentheses right after it, immediately after it. In addition, if we annotate the property, so we'll say a property, explicitly we'll set the type to int, what we have now is essentially the value 1 being assigned to a property. This is a very roundabout way of simply assigning 1 like we did earlier, but it opens up some interesting possibilities. So here we have an anonymous function that returns the value 1 that is immediately called. So this executes and we return 1 and we assign 1 to a property. Using these anonymous functions, we can group together logic related to our elements all at the point of creation. So everything related to the label can be put in this one place. Let's start and we'll try this with the story label. So rather than assigning an instance of UI label directly, first we're going to get rid of this instance that we're assigning here. Make some room so that we can see what's going on. And again, we're going to explicitly specify the type as UI label. Now the reason we're doing this, like we did here with int, is because we're assigning a function here, we need to let the compiler know exactly what it is we're returning from the function and what the type of this property will be. So let's get rid of this. We don't need this anymore. Now, to this property, again, let's assign an anonymous immediately executing function. So set of braces, just like a function body. And then right after it, we'll place the set of empty parentheses to call the function. Now we have an error, and that's because this function is expected to return a UI label value, since that's what we told the compiler will be the final value that comes out of it. Now inside the function, we can set up the instance of the label. So we'll say let label equal, we'll create a new instance of UI label, and then we can go ahead and return it. And now story label is this instance of UI label, except that since this is a function, rather than writing a function below and assigning the value to this property in viewDidLoad, we're assigning the function and calling it immediately right here. So whatever is in this function is executed, and that value is assigned back to story label. So inside this function, inside this closure, we can also customize the label. So we can say label.translates auto-resizing mask into constraint equal false, and label.number of lines equals 0. So now that we have this code in here, this is the same customization we're doing inside view-with-layout subviews. So if you look here, we're first adding the story label as a subview, then we set the number of lines to 0 and turn off the auto-resizing mask into constraints property. We've already done that, so we can get these lines of code out of here. Let's do the same thing, the same basic trick. It's not really a trick, but the same basic thing for all of the views that we've added to this view controller. So instead of assigning an instance of UI image view, we'll set the type to that, and we'll assign a function that we call immediately. Inside the body of the function, we'll create a new image view, UI image view. We'll return it so that now we have an instance assigned to the property. And then we can customize this. So we'll say image view, and we'll do the same basic thing. Translates auto-resizing mask into constraints false, which means now we can go down to view with layout subviews. Down here, and we'll remove this property as well. So we'll clean it up a little bit more. We'll go back up, and we'll do the same thing for the buttons. So here we want to set the type on first choice button explicitly to UI button, assign a function that we call immediately. And in here, again, we'll repeat the same basic code that we have. So let button equal UI button. Use the type initializer and specify a system button. We'll set the button's auto-resizing mask property to false and return it. Since this is the exact same way the second choice button is set up, we'll grab all of that and assign it right here. So now we have all this grouped in one area. We can go down to view with layout subviews, and we'll remove this and this. Okay, it's somewhat better. We've removed some setup code from a different method and put it in the same place that we're creating the view. But we didn't get rid of a lot of code. So in the next video, let's focus on slimming down viewDidLoad even more.